Our next example pattern is synchronous web service. A synchronous web service is used when the calling system needs a response immediately. In this case, the calling system blocks on the called thread and waits until it receives a response or either times out. Boomi allows you to expose an existing process as either a SOAP or RESTful web service. While setting up the web server configuration, you can indicate if a response is expected to be sent. This can then be consumed by different client applications or even by another Boomi process. You can make use of this pattern when you want to expose business logic as a common service accessible to multiple clients, or when the sender wants to know the result of an action immediately, or when the value of information being retrieved is valid only at that instant in time. So an example of this is a retrieval of information from a business process. This process could be a single process or a combination of processes, which may involve computation. This is a diagram of the solution. So first, Boomi will listen for an HTTP input request to the Boomi Web Service server. Next, it would do required business processing. This could be a database lookup, the web service call, or a series of process calls. The only condition common to them would be that the process has to block and wait. If the response is not received on time, it must time out and inform the sender system. In the case of an error, you map the error to the expected response and send it back to the sender. The return response is then received by the source system. There are some things to be mindful of when you design and implement with this pattern. First is network latency. On some networks with high latency, this pattern does not lend itself well, as frequent timeouts would lead to system unreliability. Consider also system availability. Error trapping mechanisms with soft landing need to be in place during system downtimes. This has to be taken care of by the system which is calling the Boomi web service. Also consider large data sets. Serializing large responses would cause performance-related issues and network congestion. In these cases, it would be better to use other patterns. If you're invoking SOAP-based web services, please note that there is a high overhead on the SOAP processing itself. And lastly, processes should always return a response to the client. Documents should not go down any paths that are dead ends. Here are some runtime considerations. There are only so many simultaneous executions that the web service endpoint can handle before it starts suffering from performance degradation. Nonetheless, make sure simultaneous executions are allowed on the process. Consider low latency. Web service processes can be set to be of low latency, which will log only in case of error. An Atom worker, when you're in the cloud, allows a persistent entity on the cloud to process incoming requests, which greatly increase the speed. And lastly, remember that the process is deployed to the Atom, so consumers invoke the web services from that endpoint directly. Here are some possible errors with the web service. The source can't reach Boomi. You'd want to check that the web service listener configuration is properly configured to handle incoming requests. There's an unexpected error during a Boomi process. Processes should be designed to gracefully capture these exceptions to return an appropriate message back to the source. There's a fatal exception in the process. For exceptions that cannot be caught gracefully, the Atom web server will return an HTTP 500 exception to the source. Boomi can't reach the target. Processes should be able to handle errors, and the source should be able to handle the exception and retry. Finally, the target returns a failed response. The process should pass target response to the source, and the source determines what to do about it. One final note, in case a web service is used for creation, idempotency should be ensured either by the messaging system or the target application. So let's take a look at this sample Boomi implementation. In step 1, we set up a web service listener. This will be listening for both SOAP and REST requests. In step 2, an optional try-catch block captures and processes any errors returned from a downstream business process call. This allows any unexpected exceptions to be gracefully handled within the process logic to return a more friendly response to the client instead of an HTTP 500 internal server error. In steps 3, there are two routes a message would take based on the try-catch. In 3A, this is a step where you would execute the business logic. In this example, a call to a subprocess which executes the logic. A successful call would result in a document response being returned. And in 3B, unsuccessful calls can be captured and mapped back to the response document and then go on to step 4. And finally, in step 4, this has a return document step. This is what indicates that this is a synchronous service.